The last group of molecules that we'll look at in terms of nomenclature are acids. We're not going to worry about bases. Bases contain hydroxide, OH, and they're named just like any other ionic compound. So we have sodium hydroxide, we can have calcium hydroxide, and you may kind of remember that from first year chem. Hydroxide is the sign of a base. Hydrogen is the sign of an acid. And I guess kind of sadly, the acids have a couple more naming rules than the bases. So we'll look at those in this video. Two options. You can have acids with or without oxygen. So here are some acids, some common acids that do not contain oxygen. And I think of these, maybe hydrochloric is the most common. You've probably used hydrochloric before. And that's exactly kind of how they're named. So if I don't see oxygen, but I do see hydrogen, and it's usually in the front of this formula because hydrogen is the positive ion, we go hydro, and then we end it with ic acid, hydrofluoric acid, hydrochloric acid, hydrobromic, hydroiodic, that one's kind of fun, hydrocyanic acid, hydrosulfuric acid. All of these are named real similarly. I can tell it's an acid. It's got hydrogen on the front end. So I know I'm going to end it with the word acid. I'll start it with hydro, and then it should end ic acid. Not bad. The acids with oxygen have a couple different options here. The most common polyatomic, the most stable, we said will always end in ATE. So for example, nitrate. Nitrate is the most common nitrogen polyatomic. NO3. This is nitrate. We had said if you take off one oxygen, that turns it to nitrite. Same charge, -1. Okay, so if I have the ATE version, and I notice that these are acids because they start with hydrogen, the ATE will just turn into IC. And then we'll end it with acid. So again, this is probably something that you're familiar with. Nitric acid. We use nitric acid quite a bit. If I have the ITE, the nitrite, hydrogen nitrite, now ITE turns to OUS. So now that becomes nitrous acid. Okay. So this pattern continues for a lot of these acids. The most common form of sulfur and oxygen is the sulfate ion. Sulfate. SO4 -2. H2SO4 turns into sulfuric acid. Oh yeah, we've used sulfuric acid quite a bit. If it's the SO3 version, the sulfite, now that turns into sulfurous acid. And so on. Acetic is a very common acid. Acetic acid. It's a polyatomic with oxygen. There's really only one version of it. So the ending turns to IC acid. IC acid. Ic acid. The same thing would happen with phosphoric acid. We could have phosphoric acid. If it ended PO3, I could have phosphorus acid. So that's kind of the rule with these oxygen acids. If it's the ATE version of the polyatomic, it'll end in IC acid, ic acid. Icky. If it's the ITE, the nitrite, sulfite, phosphite, then it'll turn into OUS acid, US acid.